The purpose of this video is to introduce slope operations. That means landing on and taking off from sloping terrain. As helicopter pilots, we are often landing in unimproved areas off airport, and many of these areas can have slopes on them. And so this is a very important procedure, maneuver to get right, not only for your practical exam. On your check ride, you're going to be expected to perform it and explain it and do it well, but also in real world helicopter operations, it's something that we are doing on a regular basis. So good to study it, know it, get proficient at it, and primarily because there are a lot of hazards. Let's start by going over the hazards associated with slope operations. These include dynamic rollover, sliding, mast bumping, tail rotor strikes, and passenger encounters. Dynamic rollover, this is a perfect scenario for that to occur. You need a rolling motion, a pivot point, and meeting or exceeding the critical rollover angle. The aircraft needs to meet or exceed its critical rollover angle. This is a condition that is solely due to pilot error and very difficult to recover from. So you want to make sure that you don't get yourself into this condition. The next is sliding. If you start sliding on a slope, that can lead to a dynamic rollover situation, because if you're skid sliding on a slope and then just to the downhill side of you, you have rocks or uneven terrain, that's going to provide the pivot point that could contribute to that. Mast bumping, if you try to land on a slope that's too steep and you want to put your downhill skid down and you run out of lateral cyclic authority to make sure that the aircraft doesn't exceed that critical rollover angle, you could then have a situation called mast bumping if you have an underslung rotor system. Mast bumping is also very serious. It could break apart your rotor mast and your rotor system. Tail rotor strikes, always want to know where your tail is in any situation, but when you're working around sloping terrain, even more so. And passenger encounters around sloping terrain, when you have passengers getting in and out of your aircraft, that definitely can be a very dangerous situation, and we'll talk a little bit about that more toward the end of the talk. So let's just talk about landing on a slope. How steep is too steep? Well, for training and real-world operations, typically we say 5 degrees maximum. If you've run out of lateral cyclic, it's too steep. So find another place to land. That's the beauty of being in a helicopter, is you can pick it up and you can move just right over there and you can find another spot that could be much better to land. You don't have to risk it just because that's where your passenger wants to get out. If you're on a job, for instance, and they want to go right there and want you to get as close as possible, well, if that little spot is not safe, then the next little spot over, that's as close as possible. They can walk. You want to be aware of your wind direction and speed, of course. If at all possible, you want to have your nose into the wind. You don't want to have a tailwind on a maneuver like a slope operation, because you don't want to have a twitchy tail. You need to have pretty precise control with your tail rotor pedals for this. You're going to check your suitability for landing. You could do a little recon like you do for other operations. Just, before you set down, you can hover around this area and find out what looks like the best place to land before you decide to set down there. You want to keep your eyes out on the horizon on a reference point like you do when you're in a hover. And you want to keep your RPMs in the green, because if this is not the right situation for you, you're going to pick it up and you're going to go somewhere else. So let's talk about how you approach. And I've got a little visual aid, a Tonka helicopter, that's going to help us kind of visualize a couple of these steps that I'm going over. So our Tonka helicopter looks suspiciously like an EC-120. Blades look kind of like they would be going in a clockwise fashion, but for the purposes of this demonstration, we're going to simulate it as a counterclockwise rotating system, like many of the training helicopters that we all use in a training situation. So when I talk about approaching the hill at a 45, you want to have your aircraft parallel to the slope and then approaching it at a 45-degree angle. So, rather than coming in from this direction and turning your tail in a way, if you're not certain what's over here, you can come in on a 45. So step 2 here would be to start your descent. You're going to gently lower collective, you're going to touch down your upslope skid, and then you're going to hesitate for a moment. You don't want to just lower collective all the way. You want to make sure that you're on supportive ground. And you want to have slight cyclic input into the slope. So we've come in on a 45. Something I didn't mention is that there are some recommendations that talk about if the direction of your tail rotor thrust, for instance, in this counterclockwise rotating system, tail rotor thrust is off the left. So you would want to have your right skid on the slope because that tail rotor thrust, that translating tendency, can help keep you into the slope. So if at all possible, again, nose into the wind, and your right skid on the slope in a counterclockwise rotating system. All right, so now we're ready to actually touch down our downhill skid on the ground. So this will be step 3, the landing. We're going to continue to lower the collective gently while applying lateral cyclic toward the slope. So here, up here we're parallel to the horizon. Again, once we start to set down, a little bit right lateral cyclic input. Now as we've lowered our collective and simultaneously added right lateral cyclic to hold us into the slope, all of this very slowly and gently, we're going to get our rotor disc now parallel to the horizon. So our aircraft is tilted this way, but our rotor disc is level with the horizon. You don't want to slide here. If you start sliding, and this is why you keep your RPMs in the green, if you start sliding, gently pick it up. You don't want to lead to a condition that's going to get you into something more critical. If you have vibrations, any abnormal vibrations or mass bumping, you want to abort. Again, you can always pick it up, put it somewhere else. So now we're in the uphill skid down scenario, getting ready to lower our downhill skid. Simultaneously lower collective while adding right lateral cyclic and imagine this rotor disc tilting into the hillside. It doesn't actually have a lot of play in this little model, but you can imagine that you would have this tilted into the hillside. And so your rotor disc is going to be parallel to the horizon. You still want to stay a little bit light on your skids until you feel exactly that you're on the ground firmly. And once you are, you can go collective all the way down. Okay, once you've determined that you feel pretty good about your situation on the slope, how secure and firm your skids are on the ground, that you're not going to slide, and that you can put the weight on the skids, go ahead and lower collective all the way. Probably want to keep those RPMs in the green in case you do decide you still need to take off, but at this point I think you're pretty comfortable with where you've got the helicopter. Both skids on the surface, and now neutral cyclic. So here you had your cyclic into the hillside, so it was parallel with the horizon. Now your cyclic is neutral and your rotor disc is going to be parallel with the slope. So now we're ready to take off. This is kind of where we left off here, where you have full weight on the skids and your rotor disc is level with the slope rather than the horizon. You're going to again note your wind speed and direction. It may have been a few hours since you've been on the ground. Things can change, as you know. Don't assume that it's exactly the same conditions as it was when you got there. You're going to clear your skids in the area. Make sure that no rocks have rolled down the hill, anything like that since you set down. You want to do your pre-takeoff checks. Have your RPMs in the green. So you want to have your eyes outside on a reference point, just like you do in a hover. When you set down on the ground, I was talking about, you'll feel when your uphill skid touches the ground. You're also going to feel when your downhill skid comes off the ground. So eyes outside. On step 2, you're going to level your rotor disc. So here the rotor disc is parallel with the slope. Here you're going to start to add right lateral cyclic, put some pressure against the slope. Now you want to be leveling the rotor disc with the horizon instead of the slope. So you're going to start to gently raise your collective. The downslope skid is going to start to rise. So this has to be very slow and controlled motion. You don't want to yank on that thing because that's how you're going to get into dynamic rollover situations. So very slow and controlled, eyes outside. At step 3, You're going to simultaneously continue to raise the collective while leveling your disc with the cyclic. Here we had rotor disc into the slope. Now that you're coming off the ground, you don't want to do that anymore. You want to have it more level with the horizon. So you're going to have simultaneous collective and cyclic input to make sure you level that disc and gently pick up your skids off the ground. You're going to maintain your RPMs with the throttle and maintain your heading with the pedals. You want to have your helicopter in a level attitude, and just before you come off the ground, again, hesitate. Make sure everything looks good. Done your pre-takeoff checks. You don't want to do anything abrupt. Then slowly raise your collective to lift off. So you're getting ready to pick up the helicopter. You want to have your eyes outside, RPMs in the green. I'm going to add some right lateral cyclic so you can get a little bit of pressure into the slope. Gently start pulling on collective. It's going to be a simultaneous cyclic and collective input here. Very gently. You don't want to do anything quickly. So just to get the helicopter level. Once you're stable, you're going to hesitate. And now you can, with your rotor disc level with the horizon, start to pick it up off the ground. So now you're going to be in a hover. Alright, once you've gotten light on the skids, you're going to pull into a 3-foot hover, do your pre-takeoff checks, clear your area, note your hover power, and then depart. So what you want to be sure to do is always move away from the slope. You can do just a sideways hover, move away from the slope till you're well clear of your tail rotor before you turn, and same kind of thing, depart at a 45, just like you came in. So from this hover, you're going to do your pre-takeoff checks. Make sure you look both ways, clear yourself. What you don't want to do is turn the tail and fly off this way. So step 4, after you get into the hover, you're going to slide to the left and be well clear of the slope before you turn your tail and start to fly away. Alright, so let's just talk a little bit about the situation with having passengers on a slope. When you're in a situation with sloping terrain, you're on the ground. So let's use this for example. Number 2, you're on the ground, you've got a passenger in the right seat, they want to get out and do something on the ground. That's why you landed there in the first place. They have to go check on something. So they want to get out. Keep in mind that the distance between the rotor blade and the ground is a lot less on that uphill side. You have to be really aware of that. And in certain kinds of helicopters, like the Enstrom for instance, those rotor blades are very low. There's not a lot of clearance there. So you need to make sure your passengers are really aware of the fact that they're low. When they exit, they need to be in full view of you, the pilot. Make sure that they never go toward the rear, they never go where you can't see them, and they stay down, because a rotor strike to the head is a very real threat here for a passenger. You don't want to have a safe landing and then have somebody get out and get knocked in the head by a rotor blade. So you want to be very clear with your passengers in this situation, because it can be very dangerous. It's a real threat. It happens to experienced pilots. You need to make sure that your passengers understand that there's a difference here, and they don't have a lot of rotor clearance. So a rotor strike to the head can be fatal, and it's important that you relay that in your safety briefing if you have passengers.